In the previous sessions, we have looked at the exponential series, e to the power of x and e to the power of minus x. And we have also seen the expansion of sine alpha and cos alpha. Now let's generate some series using these expansions. So e to the power of I theta, what would be the expansion of this? So let x equal to I theta. Substituting x with I theta in e to the power of x, we get e to the power of I theta is equal to 1 plus I theta by 1 factorial plus I theta square by 2 factorial and so on. Simplifying this, we get 1 plus I theta minus, because of this I square, theta square by 2 factorial minus I theta cube by 3 factorial plus theta to the power of 4 by 4 factorial and so on. Let's group real and imaginary terms. So we end up with 1 minus theta square by 2 factorial plus theta to the power of 4 by 4 factorial minus dot dot. And the imaginary part would be theta minus theta cube by 3 factorial plus theta to the power of 5 by 5 factorial minus dot dot dot. Now, what is this series? You will notice that it is the same as the series for cos. So, and this one is the same as the series for sine. So we end up with e to the power of I theta is equal to cos theta plus I sine theta. We have already seen this previously. So a famous equation involving e, I, pi, 1, 0. Let's look at that. So let theta be equal to pi in e to the power of I theta equal to cos theta plus I sine theta. So we have e to the power of I pi is equal to cos pi plus I sine pi. Cos pi is minus 1, sine pi is 0. So minus 1 plus I times 0, which gives us e to the power of I pi is equal to minus 1 plus 0. So we end up with that famous equation. E to the power of I pi plus 1 is equal to 0. Now, since the next result we are going to be using later on, let's see what happens when theta is equal to pi by 4. We get e to the power of I times pi by 4 is equal to cos pi by 4 plus I sine pi by 4 is equal to 1 by root 2 plus I 1 by root 2, because cos pi by 4 and sine pi by 4 are both 1 by root 2. And combining them, we get e to the power of I times pi by 4 is equal to 1 plus I by root 2. Now let's look at e to the power of minus I. We substitute x with minus I theta. E to the power of I times minus theta, we can write this as this, is equal to cos minus theta plus I times sine minus theta. Cos minus theta will be equal to cos theta and sine minus theta is equal to minus sine theta, which means e to the power of minus I theta is equal to cos theta minus I sine theta. Now we come to cos theta in terms of e. So we add e to the power of I theta with e to the power of minus I theta. We get cos theta plus I sine theta plus cos theta minus I sine theta. I sine theta minus I sine theta cancel out. We are left with 2 cos theta. And which means cos theta is equal to e to the power of I theta plus e to the power of minus I theta divided by 2. Sine theta in terms of e. Now we subtract e to the power of I theta minus e to the power of minus I theta is equal to cos theta plus I sine theta minus cos theta minus I sine theta. Now, in this case, once we open this brackets, we get cos theta plus I sine theta minus cos theta plus I sine theta. cos theta cancels out, and we have e to the power of I theta minus e to the power of minus I theta is equal to 2i sine theta, which means sine theta is equal to e to the power of I theta minus e to the power of minus I theta divided by 2i. Once we have worked out these things, you see how easy it becomes. Now, other trig functions in terms of E. Main is tan. So tan theta we know is equal to sine theta by cos theta. So we just take these two and substitute. So e to the power of I theta minus e to the power of minus I theta by 2i divided by e to the power of I theta plus e to the power of minus I theta divided by 2, which we convert it into multiplication, and we end up with e to the power of I theta minus e to the power of minus I theta divided by I times e to the power of I theta plus e to the power of minus I theta. Now, what about sec, cosec, and cot? Those will be just reciprocals of these. So, pretty straightforward. Now, homework for you. Hyperbolic trigonometric ratios. I'm giving you the expansions, and in terms of E, you have to prove the above statements. Derive the expansion for hyperbolic sine and hyperbolic cos. Derive the hyperbolic sine and hyperbolic cos in terms of E. Add, subtract them, and arrive at the appropriate E expressions. And since you are at it, try for the other hyperbolic ratios as well. So that was trigonometric ratios in terms of E. Now, if you found this session helpful, please do like, share, and subscribe. Questions, suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.